Okay, so this is the fourth video, and so far we've looked at construction of a growth gap or a kind of output gap that we'll use as an input into the Taylor rule in estimating Taylor rule coefficients. For the Taylor rule, of course, we need Fed funds data. We need inflation, and we need output gap. So these are the raw data that we're looking for. So GG. Again, a good source of this data is FRED database, Federal Reserve St. Louis, and we go to the database and we're looking for, well, we're looking for CPI data, and we'll have a look at this. So this is CPI, Consumer Price Index for all urban consumers, all items, and it goes back to 1947 as well. So let's download this data. Download, and it is an issue here is it's monthly, and our GDP data was quarterly, so maybe we'll change this to quarterly. And okay, so it's averaging. Let's download that. And also we want interest rates, so let's see, popular series Fed funds is effective Fed funds interest rate. Okay, let's take this one. And this is back to 1954. Okay, and it might be daily. Let's see if we can get quarterly. Okay, and it's a percentage. So let's download this. Check Excel. Okay, so I need to download, but not monthly, quarterly. And let's download this data. Okay, and open up. And we can see the detail here in the data. Let's just copy this. So enable editing, copy. Go back into the main spreadsheet. I already have written in here Fed funds. Let's just paste in as is. It's quarterly. Let's just verify that it's quarterly. Okay, it starts. We'll call it Fed funds. Okay, and for inflation data, inflation. So we could, looking at this data, it's clear that it's not a percentage change. Actually, it's inflation index. So we could go back to FRED database. So let's go back and go back to Consumer Price Index. And we could come down here to, okay, we want a frequency of quarterly. And instead of the change, we could look at percentage change from a year ago. So let's just eyeball that particular data, and of course go back to 1947. You can see the early Volcker period when inflation peaked, and then with substantial monetary policy, aggressive type monetary Fed fund setting, monetary targeting, the inflation rate dropped here, and then we move into the Greenspan period where we have a more benign interest rate inflation type of environment, and then we get into a period of financial collapse, deflation, and then back to what we currently have, kind of benign inflation verging on deflation. Okay, so let's see if we can download this data. Download data. Let's go back now. It's still giving us index, so I think we'll do percent change from a year ago. We could do continuously compound rate of change. Okay, I'll go percent change from a year ago, and I want quarterly. We're taking average, and let's download that. And let's open that up and enable editing. And it's quarterly. It's the average of, I think it's daily figures. And we don't, okay, we lose the first 4 observations. That makes sense. And again, this is a percentage amount. So let's just copy that. Copy. In fact, let's copy everything here. Copy. And go back into the main spreadsheet where most of my workings are, the inflation data, and just paste from here. Home, paste. Okay, so from cell, yeah, should be from here. Home, paste. So percentage change from a year ago, and we have daily, we have annual observation, quarterly observations of annual inflation. So each year has 4 quarters. Okay. Okay, so let's take this inflation data to start with. And maybe I'll just write inflation here. And let's copy. Copy. And go back in where I have the data, and I'll just paste. Okay, and it's 1947. Next we could take the level of, well, so that's inflation. Let's have a look at the Fed funds rate, and that's from 1954. So we have to be careful how we align the dates. And copy, and go back to, and we said it is starting from 1954-71. 1954 71. So I should be starting here. Let's just see, does it align, paste, and it's Fed funds. Okay, so it's the same starting date, 1954-71, 1954-71, that's Fed funds. And then the last one here is our GG. Okay, let's take this set of figures and copy, and the start date is 1947-011. So let's go back, let's go to the first few cells. Okay, it cannot be that one. And let's just do a paste. Home, paste. And did the dates line up? 1954 7. So okay, it's what we have to do, we'll delete these 2 columns. So just delete it out. No, oops. Let's okay, let's copy, and let's paste in, paste special values. And when I delete, the growth gap still is good. Delete. And the 1947 doesn't align here, so we need to take this, just delete this up, shift cells up, and now 1947 aligns with 1947, and that's the annual growth gap. Probably should multiply this by 100, just expressed in terms of percentage, so multiply by 100. And let's bring this down. So we have a percentage amount. Okay, we can delete the last row. And let's just eyeball this again. So 1947, 1947-01, and 1954-71, 1954-071, 1954-71. That's fine. Okay, so we have inflation. And next one is Fed funds. And next one is growth gap, GG percentage. Okay, and we can delete. Let's delete these out. So delete. And so we have, looking across, 1954-041, 1954-07, and the date. Okay, so that's that date. Okay, 1954-7, 54-7, 54-7. Okay, so that looks fine. So we just remove this row here, delete, and we have 1954, 1954, 1954. We can remove this growth gap, delete. Oops. Let's see. Yep. I must copy and paste these values. Paste special. Paste special values. And then I can remove. Delete. Now, the array for Taylor rule, if we just go a little bit further into Orphanides' paper, normally the representation of the Taylor rule is the Taylor rule. So inflation and output gap is regressed onto the Fed funds rate. So R denotes the Fed funds rate. Also, in the representation that, so if we go back to the original, so here Orphanides has summarized the Taylor rule to be Fed funds rate 1 plus 1.5 times inflation plus 0.5 times the output gap. Now that looks very different to the original Taylor rule as set out by John B. Taylor in 1993, but however it is in fact identical in terms of it. If these values are rearranged, they collapse to a simpler representation of 1 plus 1.5 times inflation plus 0.5 times the output gap. Okay, so that's something that we might note, that when we estimate our Taylor rule, which we will do in a moment, we get we can examine our coefficient estimates against the values here, 1, 1.5 and 0.5. So in the next video we'll estimate the Taylor rule.